Welcome back. As you know, I am Eli the Computer Guy, and in today's class, we are going to be creating Python scripts that allow us to compare the results that come back from different large language models. So now, in the modern world with large language models, there are a crap ton of them that you can use. Some of them are small, some of them are large, some of them are fast, some of them are slow, some of them are precise, some of them give you really weird results. So one of the problems that you might run into is basically the question of which large language model should I use? And so what we're going to be doing today is we're going to be using Ollama. If you don't know about Ollama, Ollama's cool. We just did a class on Ollama. So basically this is a framework that allows us to run large language models on our local machine. So we're going to use Ollama and we're going to download multiple different large language models onto our local machine. And then what we're going to do is we're going to have a Python script and we're going to plug in what our request is, what our query is, and then it's going to do a loop and it's going to go to whatever language models we tell it to go to, and it's going to pull back the results from those models. It's going to show us how long it took to get the results, and then we can sit there and we can take a look and we can say, okay, this is the query that we inputted, and then here are the 2, 3, 4, 5, 10 results that we got back. It's dynamic. We actually just create a list for the LLMs, and then we can determine which LLM is giving us the results that we want in the time frame that we want. And so basically that is what we're going to be building in today's class. So let's go through a few demonstrations so you understand what we're trying to accomplish in today's class. The first demonstration script is basically a command line script, and what we're going to do is we are going to have this text file. So this is a text file that has information about our business. We have hours of operations here, and we're a restaurant, so we have side items, fries and salad, we have sandwiches, we have entrees, and we have drinks down here. So basically the idea is that we can ask these LLMs questions about information in this text file, and it'll give us responses. I will say it will give us responses. Whether or not they're correct responses, that's a different story. And so basically what I can do is I can click on the Run button, and this pops up, and it now says, how can I help you? And so I can plug in. Imagine if this is a restaurant, and I'm trying to figure out if they have vegan options. What vegan options do you have? So I can simply ask a question like that. What vegan options do you have? Then I can hit enter, and now it's going to be processing through. If we go back and we take a look at info.txt, so this is a thing. So what vegan items? We have fries, we have salads, we have a veggie sandwich, we have a portobello sandwich, we have a vegan lasagna, and we have soda and water. So those are the vegan options that are possible. Not necessarily what we're going to get. Okay, so we have from model, Ollama 2, 7B, the 7 billion parameter. Response, the vegan options are the veggie sandwich for $9 and the vegan salad for $20. And that's all we get for the 7B version. If we go down, we go through the 13, Llama 2, 13B version, and we get the veggie sandwich, the portobello wrap, and the vegan lasagna. So those are here. We also have this time, so it shows that the first request took 7 seconds. The second request for 13B took 15.17 seconds. Model Pi, oh my golly, this just gives us a response. Like, look at this. Like, Llama 2 7B, that's a response. Llama 2 13B, that's a response. Pi, so this is Microsoft's model. Response, sure, here are some vegan options based on the menu items provided, fries and soda or milkshake. That's not vegan. Salad and water or milk. That's not vegan. Veggie sandwich, okay, portobello wrap. Remember to check with your server, and then it just gives you so much more. So, what the hell? I don't even know what this is. This is not even a joke. And anyways, and that came back in about 10 seconds. And then we have the Mistral model down here. Response to vegan options of the establishment are sides, fries, and salad, sandwiches, veggie sandwich, and portobello wrap, entrees, vegan lasagna, and drinks, water. So Mistral is probably the best response here, and we get this back in 7 seconds. Now, the important thing, again, one of the things you have to be thinking about if you're going to be coding, right, is how are you going to parse the response? It's It's not simply good enough that the LLM gives you a response, but how are you going to turn that response into something to actually give the end user? And that's the other interesting thing with this is you can take a look and you can try to figure out, how would you code to parse this particular mess? And so this is the command line version. Now, if we go over here, basically this is a web app version. So it's the same type of thing, only we have a web app and a SQLite backend. So if I run this, so I'm using Bottle, if you follow me, I like Bottle. Let me see here. We go to 127.0.0.1. And now we have this web app. So these are the previous queries that I've done, and they're basically they're together for the query. What days are you open at noon? Mistral, Pi, Llama 2, 7B, and it gives you all this information. But this actually gives it to you in like this web app format. So I can come here and I can say, how much is a burger and fries? Again, think about that. That's one of the big things with LLM. That's supposed to be this natural language processing that I can just plug in whatever question I want, and it'll give a response. One of the interesting things with this is realizing how bad the LLM responses actually are. I may have to do a little bit of a time speed jump cut here just because this does take a while. So this is actually processing through 4 different requests. So it goes through Mistral, it goes to Pi, it goes to Llama, and it goes to Llama 2 7B. And so all of that together, takes about 30 or 40 seconds. Okay, so there we go. Now we have our answer. From Mistral, a burger and fries from this establishment costs $11, since a burger is priced at $10 and a side of fries is $1, right? Based on the information provided, a burger and fries typically costs around $15. This includes the cost of the sandwich at $10 plus any sides like fries and an additional cost of $5. Again, where does that even come from? Llama 2 13B, a burger and fries would cost $10 for the burger and $1 for the fries for a total of $11. There we go. And Llama 2 7B, a burger and fries at this restaurant costs $11. And again, this gives us our little time codes here. And so this is for if we're going to be asking a question about, again, a type of data file, text file. The other thing that we can do, though, is basically, we're going to close out of this, and the final demonstration is basically where we can just ask a random question. Again, if you want to play with this and you don't want to focus on actually pulling information out of a file, because again, it's quirky. It gets a little dispiriting after a while if you try to pull information out of a file. So this particular script allows us to just simply ask a question. So we can run this. It goes to, again, 127.0.0.1. Let me just open this up. Okay, so basically this is the same type of app. It's just not reading from a text file like before. And I can say, I don't know, how do you make ice cream? I don't know, some random question like that. And then we can hit submit. And it'll give us a whole long explanation from all of these different models on how you do something, such as create ice cream, which is kind of interesting. I do find that the LLMs seem to be better when you don't feed them information. Like if you just ask them like random questions, like how to make a sandwich or whatever, they actually do pretty good. If you ask LLMs to tell you a story about a snail and a sailboat, they will give you that story lickety-split. They do a great job of that. If you ask an LLM whether a particular store is open at 7 o'clock on Fridays, it's not so pretty. Anyways, for this, how do you make ice cream? Mistral, to make ice cream, combine ingredients as milk, sugar, blase, blase, blase. So these are all within pre-tags. I just want to show you so you can know how to try to parse the information when you get it. So this doesn't have to look like this. I just have them in pre-tags. I'll show you that in the actual code examples. Pi here, I don't have personal beliefs or thoughts, but I can provide a general explanation about. Oh, oops, that's how do you jump. Oops. I lost it. Okay, there we go. To make ice cream, mix together heavy cream, milk, sugar, your desired flavorings, pour the mixture in. Llama 2 13B to make ice cream. It actually gives you ingredients here. It gives you full instructions. And 7B, it also gives you the ingredients, but more in that line. And so again, this is going to be one of those important things for you to be thinking about with these large language models. Again, one of the most frustrating things, I'm about to lose my mind. I was just at a meetup last night. Man, people are just like AI, 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 but they don't really talk about like the actual product, the actual technology, and it gets to be so frustrating. One of the problems that we have right now is, again, everybody is talking about LLMs. LLMs are X, Y, or Z. But one of the important things that you need to be thinking about as a professional isn't just simply the concept of the LLM, but again, what does the response look like when it comes back? How easy is it for you to parse the response when it comes back? Does it give you all of the information that you need? Again, one of the big things to be thinking about with decision systems or knowledge systems is that it only needs to give you exactly whatever it is that you need, right? So if it only gives you a very short answer and that's all you want, getting short answers might be the way to go. Again, how long it takes to process a request, right? So Mistral takes 7 seconds, Pi takes 3 seconds, Llama 2 13B takes 17 seconds, Llama 2 7B takes 6 seconds. Again, if you are going to be putting this on a system that will have load, right? If you have 100 users a minute on your system or 100 concurrent users, which one of these different models is going to work better for your particular situation? And so basically the class today, I'm going to show you how to write this code so you can, dump in whatever model you want onto your own system and then, see what results you get. Oh boy, so it's my favorite part of the class. I always love getting into the architecture. It's the real nut meat of these classes, I think. It's one of those things that's interesting and technical, but not too technical that you trip over your words when you're talking about it, right? So anyways, for this particular system, what I'm going to be showing you today, everything is local. And so one of the valuable things about that is you are not going to be making API calls, so you don't have to worry about costs, you don't have to worry about security issues, you don't have to worry about networking issues or anything like that. Everything that we're going to be doing today is going to be running local on our local machine. Now, it is important to understand whenever you run this is that I am using an M2 Max, I guess, a MacBook Pro that's about 1 year old in my time frame from 2023. It does have 32 gigs of RAM. It has that M2 Max processor, so on and so forth. So one of the things that you just have to kind of keep in mind is with these different models, depending on the resources on your computer, you may or may not be able to run different models. So the smaller models should run fine. Llama 2 7B should run fine for you. Pi, PHI should run fine for you. Some of the other models should run fine for you, but if you run into problems where it's bogging down, your computer just might be too slow to do this. So if you have a system with 8 gigs of RAM, God help you. Maybe something will work, who knows, but you're going to want at least 16 gigs of RAM most likely to do most of what I'm going to be showing you today. So anyway, so with this, we are going to have our machine, right? And so I have a Mac, but again, you can have Windows or Linux or whatever else. It should work fine. We are going to install the Ollama framework like I showed you before. So Ollama.com, you simply go to Ollama.com, click the download and install, and it's really, really simple. From there, you're going to need to go to the command line, and basically you're going to need what's called the pull command. And so what the pull command is going to do is that is what will pull down the different models for you. So not all the models are not loaded by default because they actually do get to be pretty big. So you will decide specifically which models you want on your machine. And so when you're going to be running this, make sure you pull the models down first or it will most likely fail out. Past that, then we're going to need to make sure that Ollama is running, right? So Ollama is a service that should be running on your machine. If Ollama is not running, the scripts will just simply not work. So if you try to run your script and it basically completely fails out, most likely Ollama is not running, and so you've just got to have Ollama run. You do the Ollama serve command that will start it if it's not already started, and if you just restart your machine, it should auto start by default. Past then, we're going to be using Python because we always use Python in these classes, and there is an Ollama module in Python. So we're just going to import the Ollama module into Python, and that will allow us to be able to interact with Python. With that, that's all you're going to really need to do that first demonstration that I showed you, where you're just doing the command line thing. Basically, all you need is Python and Ollama, and it'll run fine. If you want to do the web app, though, in order to do the web app, you're going to need to use Bottle or whatever you prefer. So Bottle is the web app framework. That's what allows us to actually use Python as a web server. So that's what presents the page to us. And then we are also going to be using SQLite. So SQLite is a relational database. And basically what will happen then is we put in our query. The query then goes to all of the different models that we're making the request from. When the response comes back, we're going to take that query, we're going to take what model it is, and we're going to take the response, and we're going to dump it into the SQLite database. So that will be our data store, so that when we go to that web page, when we go to 127.0.0.1, that's what will then present a nice little report, because we'll simply be able to do a select all statement from the table that contains this information, pull that in, and then basically loop through and spit that out. So this is essentially what the architecture looks like for the system today. You need Ollama. You need Ollama to be running. You need Python. We always use Python. You need the Ollama model. We're going to be using Bottle, and we're going to be using SQLite. Again, these can be swapped out as you see fit. If you know enough to swap those out, by all means, swap them out. If you don't know enough to swap them out, don't swap them out. The reason I use these is because they're incredibly easy for new people to use. So now the first thing that we need to do before we get into the code is we need to make sure that Ollama is installed, that Ollama is running, and that we have pulled down the models that we care about. So I'm using this Mac, and it's probably hard for you to see here, but up here in the little taskbar or whatever, there's a little llama. Right? So if you see a little cute llama up here and you're using a Mac, then you know that Ollama is running. Again, with Windows or whatever else, you should see an icon like that. If that is not up there, you can use the command Ollama and simply serve, and that will start the Ollama service. As we can see, there is an error because it's already in use, so we're not going to worry about that today. From that, we can see what models are already installed onto our system. So if I do Ollama list, this will show me the models. And so you can see here, I have Ollama 2, 13B, 70B. Don't try to do 70B unless you got a really good system. I've got 7B chat. That's a different version. Llama 2, the latest. We have Mistral, we have Mixtral, and we have Pi. So this shows us the different models that are on the machine, when they were modified, or basically when they were installed, and the size of these things. Again, depending on your system, especially if you bought a Mac, you might have to worry about the storage on the Mac. Look, I love my Mac. I love a lot of things about the Apple ecosystem. The default storage size is not one of them. And so like with Mixtral here, you can see that takes up to 26 gigs of storage on your machine. Llama 2 70B, that takes 38 gigs of storage. And so if you add all of these up, you know, you're already getting up to about 60 gigs of disk space that's taken up simply for these models. So that's one of the things just to kind of keep in mind with this. Again, especially if you have a Mac, make sure you don't bog down your entire machine by downloading all of these different models. Let me just clear the screen. If I want to pull down a model, so there's a whole bunch of different models. If we go over to Ollama, we can take a look at this. So again, we can just go to ollama.com. That's all that is. We can go over here to models. And when you take a look, they have a metric crap ton of different models. And again, this is one of the reasons why today's project is pretty important, is because it can be very difficult to understand which model you should use for whatever system you're going to be putting into a production environment. And if you go through, you can just see there's a crap ton of them, like Pi. So Pi is small. Pi 2, a 2.7 billion parameter language model by Microsoft Research that demonstrates outstanding reasoning and language understanding. We have Orca, a general purpose model ranging from 3 billion to 70 billion, suitable for entry-level hardware. Dolphin Mistral. Again, you've got Llama 2 Chinese. Again, if you're dealing with Chinese clients or whatever, Tiny Dolphin. You just have so much stuff. A Tiny Llama, 1 billion model on 3 trillion tokens, open chat, so on and so forth. So anyways, basically, if you want to pull down a model, all you do is use the command Ollama. Once Ollama is already installed, install it. It's very simple. Ollama, and then you simply say pull. You want to pull, and I'll do Llama 2 colon 7B. So that's one of the models. Then I hit enter. It'll pull the manifest. It's already actually, as I've showed you before, this is actually already installed onto the system. So all it was doing was verifying that everything was correct. And so now I have Llama 2 on the system. So these are the things that you need to be thinking about with Ollama. Make sure that it's installed, make sure it's running, and then pull the models that you're going to be using. So now let's take a look at the first code example. So this will run just on the command line. There's no web browser, there's no SQL database or anything like that. This is the simplest version of what we're going to be creating today. So with this, what we're going to do is we're going to need to import the Ollama module, because that's how we do. We're going to import OS, and we're going to import the time module. Then right here, what we're going to be doing is we're going to be pulling in the file for info.txt. So I've created this info.txt file. Again, let's say for a restaurant, hours of operation, it gives the hours of operation, and it gives the menu items. So you could statically create this like I did, just simply type out a whole bunch of information, then ask questions about it. Also, do realize you could actually create this dynamically. So you could have information about your business stored into a database, again, like SQLite or any other kind of a relational database. And then whenever you fired the script, you could actually do a query against the database, pull all the values out of the database, dynamically write them to a text file. And then once you have that text file, you could then pull all of that information into your Python script, something along those lines. So that's one of the things to consider. But for this class, we're just going to have a static file here, again, with hours of operations and menu items and that type of thing. So basically, current directory equals. So all of this right here is basically that file is in the exact same folder as this script. And so remember, when you read to files and when you write to files, by default, it will always go back to your root directory. So whatever your user root directory is, we don't want to deal with that. We actually want it to be in the directory where this script is. So that's why we go through this whole mess. So we get the current directory as we've done before, what the file name is, and then we do os join the current directory with the file name, and that gives us our file path to the info.txt. With open file path, R for read as file, and then data is going to equal file.read. So we're going to open the file, and then we're going to read from the file, and that will now be our data variable. Then we're going to come down here. This is where the query is. We'll go into that in a second. First thing we're going to do is just to clear off the screen, we're going to do os.systemClear. So os.systemClear will delete everything that is on the screen. I then create a list of our models. So depending on, again, how many times you want this to run, you could have 2 models in here. You could have 20 models in here. The cool part about doing a list like this is it's dynamic. So basically simply run through however many models you have. You just plug in the name of the model. So Llama 2 colon 7B, that's for the 7B version. Llama 2 13B. Pi, or Mistral. So what this is going to do is it's going to end up looping. We'll do 7b, then it'll be 13b, and then it'll do pi, and then it'll do Mistral. That's one of the values about having this function up here. We can loop up to the function, get the results, loop up to the function, get the results, so on and so forth. We're going to come down here. We're going to do a while true. So what this does is we ask a question. We're going to get the responses back, and then it will allow us to ask a question again. So instead of having to constantly rerun the script, a while true loop will just keep this script going for us. A query equals, so what question are we going to be asking? Input function, how can I help you? os.system, so when I hit that, so I enter, how can I, the question that I want, it's going to clear the screen. It's then going to print out question and the query, so that's going to show up on the screen. And so for LLM in model, so this is the model list. So for each LLM in the model, answer equals ask, query, LLM, and data. So query is our question, LLM is the model we want to use, and data is that text file. We are then going to go up to the ask function. Right, so and here's the ask function. So to find ask is query LLM data. Start time equals time.time. So I want to see how long it takes each one of these different models in order to produce a response. And so we're going to have, this is going to be the start time. Query equals answer this user's query, so question, again this is an F string, based on the information in this data, and we plug in the data, Be as succinct as possible, just answer the specific question with no other information. This right here is where you get to have the fun of prompt engineering. Something that should be simpler than it is. Coming up with decent prompts is really a pain in the butt. Anyways, response equals Ollama.chat model. So the model is LLM. So query goes here, data goes here, LLM goes here for the model. Message equals role, user, content query, right? So new query equals the old query plus data. That goes into here. Response is going to equal response at message at content. So we don't want everything. We just want the content value that comes back. And then time elapse equals time.time. So the current time minus the start time. And that'll tell us how many seconds, hopefully seconds, have passed. We are then going to return both the response, so the response, and we're going to return the elapsed time. And so now what we're going to do here is we're going to then print the model. So what model we used? The response answer 0. So answer, response is at the 0 index, and time is at the 1 index, and that will print out on the screen. And it's pretty simple. So again, if I do this, it says, how can I help you? And I can say, are you open at 7 p.m. on Friday? Now it's going to be going through. So this is the first one, model Llama 2 7B. Yes, we are open at 7 p.m. on Friday. So if we go over and take a look at info.txt, we can see on Friday, we are open from 12 p.m. to 8 p.m. So that answer is in fact correct. So that was 7B. 13B, response. No. What? I am not open at 7 p.m. on Friday. My hours of operation are 12 p.m. to 8 p.m. on Fridays. So it literally says I'm not open at 7 p.m., but I am open at 7 p.m., right? Again, and this is the kind of weird stuff you get back. Pi. Look at this. Look at what pi gives you. I don't understand what pi is doing. Pi. Yes, I am open at 7 p.m. The hours of operation for this day are 12 to 8 p.m. Additionally, we have a variety of menu items, including sides such as fries and salad. I do have to say, can I be honest with you? Having previously been a business owner with employees, I do kind of appreciate pi for this. Pi is literally upselling the customer simply from the response. It's like, yes, we're open. Would you like some fries with that? I gotta say, from a technical standpoint, pi annoys the crap out of me. But at having been a previous boss that's written people's checks, there's a little part of me that's kind of appreciates that it's already trying to upsell people, even from a command prompt. And then that took 3.5 seconds to come back. And then we have Mistral response based on the provided data. I am not open 7 p.m. on Friday. My hours of operation for that day are listed at 12 p.m. to 8 p.m. And that took 42 seconds. And so again, this is a thing that really shows you in the barest way possible, basically how different the responses can be from the exact same query, from the exact same information given to it, just depending on the different models, how varied the response, and also things like how long it actually takes you to get that response. So this is the first code sample. From this, we'll go over the web apps. Now that you know how to create the command line version of this, let's create a nicer web app version. So we're going to be using Bottle. Again, you can swap out with Django or Flask or whatever you want to use. We're going to do from Bottle import, route, post, run, and request function. We're going to import SQLite 3, so we have that database backend, import OS, Ollama, and time. Then we're going to go here, and this is the whole thing basically to be able to import the info.txt file, again, with the hours of operation and the items, that kind of menu thing. So, the current directory, the file name, we're going to join that together to a file path. We're going to open the file path as file. We're then going to read all of that information into the data variable. So the value for the data variable will now be whatever is in the info.txt. We then have a class for database. So this is kind of a copy and paste. I've been liking this database class I've been using for a while. And basically this just simply allows me to very easily, redo whatever steps I need to do in order to interact with a database. So it's class of database. We're going to define the path function. And so this is the path to the database. So we're going to have a database called query. I want this to be in the current directory. And so query with current directory, we're going to join for the file path, and we're going to return the file path whenever we need the file path to the database that we're going to be connecting to. We're going to have a function for create the database. So the file path equals that database.path, that function I just showed you. We have the connection for SQLite, as I've shown you in different classes. And then we have a create table SQL statement. So create table, if not exists, result. So we're going to create a table called result if it doesn't already exist. We're going to have an ID, which is going to be our primary key. We're going to have the model. What LLM are you using? That's going to be text. The query, the question as text, response as text, and then time, I just have that as text to make it easier. So this is the elapsed time, how long it took. Cursor.execute, the SQL statement of create table, and then you have to commit. Always in SQLite, make sure you commit or it hasn't happened. If you don't commit, it didn't happen. If you like it, then you better put a commit on it, as they say, and then we're going to close the connection. Here we have the statement for select. So we're going to select information out of the database, select all from result, order by ID descending. This will pull all the results out. We'll deal with that later. And then here's where we have the insert. So insert into the result, the table, model, query, response. So this is where we're going to be inserting using the SQL function. Here's where we have the ask function. We're going to deal with that in a second. And then here is where we have the index function. We'll also deal with that in a second. So these are decorators here, the @route decorator for root. So when you go to 127.0.0.1 or whatever your IP address is or whatever your domain name is, it'll automatically drop you into the index function. And for post, so we use the post decorator for this. And so when we're going to post a value, we need that decorator. So with that little question at the top, when we ask a question, we need to use post. Then down here, we have the database class .db create. So in the database class, we're going to run the db create function. And so if the table does not exist, we are going to create that table. Run host at 0.0.0.0. So any IP address associated with this computer will be able to provide the website to us. Again, we're just going to be going to 127.0.0.1, port 80. Now, if you're using a different operating system, so I'm using a Mac OS, I can use port 80 without any problems. So port 80 is like the default port for web browsing. If you're using a different type of computer operating system with different security, you might have to use port 8080. So that's just something to keep in mind. So you would do 127.0.0.1 colon 8080 to get to that 8080 port. If you have 80, it's the default, so you can just use 127.0.0.1. Debug equals true. So again, if there's any problems, I do want to see what those problems are. We go here to the index. So query equals request.forms get the query value. So down here, we're going to create a form. So form action is post, question, text area, column 50, row 1, name query. That's what we're going to be pulling from. Right? And so basically, that is where we're going to get this value. Model. So again, we can put in however many models we want, so it'll dynamically run. Llama 27B, 13B, Pi, and Mistral. If query does not equal none, so that's one of the big things with these kind of queries. Like if you have a blank request, you don't necessarily want that to run. It's going to put crap into your database and that type of thing. So basically, essentially what this means is if there is a query, then run the query. If not, don't. So for version in model, and so basically this is for the LLM. So each one of these in the model, right? Response equals ask. So the response function, query version data. So we're going to go up here and we're going to look at this. And so for here, I actually have this as query LLM data. It's the importance is the position, not necessarily the name. So this is the question that we're asking. This is the model that we're using. And this is the data file. Start time equals time.time. Again, the query and the data as we did before. Ollama chat, the model equals LLM. We're going to get the response back as we did before, message content, and we're going to get the elapsed time, and then we're going to return what the response is from the elapsed time. And so this is going to loop through all these different models. Then we're going to do database.db insert, so the version, the LLM, the query, response 0 is the response, and response 1 is the elapsed time for the response. That will get dumped into the database, and then print the response out on the command line on the screen, just so we can see what's going on. Record set equals database.db select. So basically we're going to go to the database. We're going to select all of the information out of the database. So if we come up here, .db select, again, select all from result, order by ID. That's what we're going to be doing. We're going to pull all of those values in for record set. We're then going to create the form. So this is the form as I showed you before. We're then going to be building. We're going to be building the results. So previous equals nothing, set new equals nothing, set old equals nothing. For record in record set, set new equals record 2. So basically, this is the query. So one of the things that we're going to be doing is we want to group all of the responses together under one query. That's what we're going to be doing here. So if set new does not equal set old, previous equals previous, we're going to create a div, a big black div around everything, and then set old equals set new. Then what we're going to do is we're going to print, we're going to add all the previous values. Then we're going to print everything out. So model equals record 1, response equals record 3, time equals record 4. And then we're going to print out the form and the previous, and we're going to return the entire page. Now let me just kind of show you something real quick. So let me run this. So I'm going to run this. Hopefully it doesn't fail. And I'm going to go to 127.0.0.1 as we did before. And so basically this is where we have the groupings. So here is the query. Are you open on Sunday? Model Mistral response based gives me this information. Model Pi response, model Llama 13B response, Llama 7B response with the times and all that. And you can see how they're all grouped. They've got this nice black div around everything. So I can see, okay, are you open on Sunday? These are the answers I got for that. How much is a burger and fries? These are the answers I got for that. What days are you open? Here are the answers. And it's all within like that same black box. That's why I'm doing this mess here with the set new equals record 2. So what the query is, if set new does not equal set old, basically what we're doing here is if everything has the same query, it's going to be in the same div box. And then as soon as a new query comes up, it will create a new div box for us to create, right? So this is one div box, and then this is the next div box, and this is the next div box. And that's basically what we're doing here with this whole set new, set old, and set new record, basically trying to compartmentalize those so they're easier to take a look at. Again, if we run this, right? So it's running right now. So I can say, I don't know, do you have chicken? Right, then I can hit run. Now it's going to go through. Again, it's going to take a couple of seconds because it's actually it has to run off of all of the different models that you have. So it'll take, I don't know what it'll take, 30 or 40 seconds. I don't know, do a little dance here. Oh, and there we go. We got the response. So do you have chicken? Mistral. Yes, based on the given data, chicken is available during the hours. Based on the information, you can have chicken based on the hours. No, we do not have chicken. Based on the data provided, the answer to the query is yes, we have chicken. So 3 yeses, a couple of no's. One of the things, though, to show you here is you will notice that like here, like the text goes off the page. One of the things that I did with this is, again, one of the things that you have to be thinking about is how you're going to parse the data. So if you're using this just as a testing routine, just to see what the results are going to be, you may want to know how the data is actually formatted. And so that's why I have here, I'm using these pre-tags. So record 3 is the response, and I'm putting the response within the pre-tags. So what pre-tags is however the text is formatted in ASCII text, that's how it should show up on the HTML page. And so that's why I did that here. If you want that to look prettier, you can remove these pre-tags and it will look a lot nicer. I left those there basically so you can see how the text is actually formatted. So you can try to figure out, again, for your particular purposes, how you'd want to be dealing with that response if you're using this in a different application. So the final project is basically giving you the ability to ask open-ended questions of Ollama. So originally I started this project because I thought it was going to be really cool. You're going to be able to ask questions, about a document, and it was going to give you these great results. Well, it did give us results, not necessarily great results. And so I decided to add this final project here to allow you to ask more open-ended questions. It does not have to revolve around that info.txt file. If you want a story about a snail on a sailboat, this web application will give it to you. So for this, we're going to import bottle as before, SQLite, OS, Ollama, and time. We're going to have the database class, and this is all going to look basically the same. The only difference here is our database is going to be question.db. So before it was query.db, this is question.db. So both of these scripts are in the exact same folder. So if you have the name here the same in both scripts, you're going to run into a bit of a disaster possibly. So I just changed the question.db there. Everything else is basically the same. We have the ask function. But with the ask function, we're simply going to add the query and the LLM. There's no other information, there's no data. Answer this user's question, what the query is, be as succinct as possible, just answer the specific question. We're going to then put in the query. We're then going to get back the response, which is the content, and then we're going to get back the elapsed time. We go down to index, and basically, again, query equals the value coming in from the form. These are the different models. If, as long as query isn't blank, we're going to ask, query LLM, then database insert, LLM query, response 0 and response 1, record set, we're going to select from the database. Here is our form as we had before. Previous, set new, set old, record and record set, and basically this is going to print everything out on the screen. So if I run this, okay, I can go over here. I can go to 127.0.0.1. And you can see, again, this is a historical context. So we can see the other questions I've asked. How do you make ice cream? We get different responses. How do you jump? How do you make a ham sandwich? Right? How do you make an Italian sub? So I can say, what is a sausage made of? They say you never want to know what's in the sausage. Well, if you tell me I don't want to know what's in the sausage, then I really want to know what's in the sausage. Okay, what is a sausage made of? Mistral. A sausage is typically made of ground meat bound together in a casing that may contain various additives. Blase, blase, oops. Blase, blase, blase. And it goes to the side because, again, we still have it in that pre. Sausage is typically made from. Llama 2. Sausage is made of meat and seasonings. So it gives us this different information. Took us 5 seconds here, 3 seconds here, 7 seconds here, and 2 seconds here. And so again, this allows us to ask more of those kind of cool open-ended questions, which, feels a little bit more fulfilling than the rather poor answers you get when you ask a question about a specific file. So there you go. There's a class for how you can create these projects that allow you to ask one query and then compare the responses from a number of different LLMs. What's great about this is it's dynamic, so those models are basically within a list, so you can add more models to the list, you can remove models from the list, and basically just wait for it to process. Again, do realize some of the models, depending on the power of your computer, may take a little while, so I'm not sure you want to put 10 models in that list, but as they say, you do you. You're going to download and install Ollama. You're going to pull the models that you need, and you're going to make sure that Ollama is actually running on your system before you do any of this. The first example that I showed you was simply command line. So we use the input function. We basically take the query, we take the information from the data file, and then we ask questions from these different LLMs. The last two, again, that showed you how to create a web app. And so basically, again, with the first one, we have that info.txt information. We're asking questions about that and getting the responses that we get, and that shows up on a nice little web form. The final one is basically the exact same thing, only we don't worry about the info.txt file to allow you to answer more, again, open-ended questions. And the real power for this is for you to get a better idea of the quality of results that you're going to be getting back, and for you to be thinking about how you're going to be parsing the information. Again, with these LLMs, one of the things that I hate is people talking about AI. Eli, what do you think about AI? I get confused, and then I realize people are talking about LLMs. These are not AI. Trigger warning, these aren't AI, right? They're large language models. They're great. They're wonderful. They've got a lot of uses. This is not artificial intelligence. But why it's important for me to delineate that is because if you think it's AI, you're going to expect the system to work in a way that is not going to work. right? If you think about it as a parsing system, if you think about it as a natural language processing system, right, you'll interact with this technology in a certain way. If you think it's intelligent, right, you're gonna try to interact with it entirely differently. And so what I want to show you here with these results is basically to give you that idea of these LLMs do act differently. The results that the LLMs give you can be all over the board. How you do the prompt engineering, right, that will define like the types of results that you're going to be getting back. And so again, this is much more airy-fairy configuration, right? If you're used to like Linux configurations, you're used to Linux configurations. With Linux configuration, this equals that, this equals that, this equals that. Uncomment this if you want this to work, comment this out if you don't want this to work, right? That's how we're used to using configuration files. What I want you to be thinking about with these LLMs is it's like, dude, man, it's like airy-fairy configurations where you kind of sort of tell the computer, like, the kind of results you'd really appreciate. Hey, computer, would you mind giving me the results that I want? Cool, dude, right? Like, that's a different way of administering a system. It's a different way of interacting with a system. And so understanding that how you're interacting with the system and what you have to give the system and the results that you're getting back is this new paradigm. That's what I want you to take away from this class, to be thinking about, again, how are you going to be implementing this functionality into your systems. When we think about AI, with AI, so many people focus on this idea that AI is the product, right? Well, AI will solve everything. That's great. I've got an LLM. LLMs won't solve much. LLMs are a piece of functionality. So again, how do you put this piece of functionality into a much larger platform? That's the kind of thing I want you folks thinking about. Again, with all this code and everything, I do not believe anything that I've done it values intellectual property rights. If for some reason it does, everything is going on to GitHub and the other places that I share this type of code, and you are free to use it. You're free to copy and paste it. Give me attribution. Don't give me attribution. I really don't care. Again, it's 100 lines of code. Doesn't matter to me, but you can use all of this to play with it as you see fit. So anyways, that's about all I've got for today. As always, I enjoyed teaching this class. I look forward to seeing the next one.